Welcome back to Suzanne's Tutoring, and this time we're talking about how to do the calculations in scientific notation. These notes that I'm showing on this video are available in PDF format for free. To just download it, go to my website, suzannestutoring.com. There is no membership, no money required. I don't ask for any information because it's none of my business. And don't forget to go to my YouTube channel, which you're probably already on, and like and subscribe. And if you can't find it, just look for the really big red S. So adding and subtracting versus multiplying and dividing in scientific notation. So this is sort of confusing for people at first because you end up getting everything turned around in your head and you do one thing, the wrong thing, on the wrong format, on the wrong equation. So like scientific notation would be, if you have like 2.5 times 10 to the second. And if you don't know how to do scientific notation, check out my scientific notation in 2 minutes or less. It's on TikTok and it's also on YouTube. So this would be scientific notation. And the problem people get into is when you end up with problems like this, like times 1.4 times 10 to the third. And you don't know how to do that. You're thinking, oh my gosh, do I have to turn all these back into regular numbers and then multiply them, or how do I do this? And then also the problem that people have is that if you have something like this plus 1.4 times 10 to the third, they want to try to do the same, they want to try to solve it the same way that they're solving the multiplication. It's different. The multiplication and division is different than addition and subtraction. You're going to solve these in two different ways. So before we go into exactly how to do this in scientific notation, let's do a really quick review so you understand why it's done this way. So what does an exponent really mean? So if you have x, just any number, this is any number, like to the power of 2 to the second, so x squared. So this 2 up here is how many times the x is multiplied times itself. And the x is the number that you're multiplying times itself. And if you have just an x, anytime you're dealing with like algebra or anything, if you have an x and there's nothing up there, that means an invisible 1. Because I said it before, I'll say it again, mathematicians and scientists are lazy, and we do not want to be spending all day writing things out if we don't have to. So everybody has just, I don't know, hundreds of years ago or whatever, everybody just decided that anytime there is an x or anytime there is a number, if there's nothing up here, if there's no exponent, it's just automatically considered a 1. You just automatically assume it's up to 1. Because if you have 2 to the power of 1, then that just means 2. Because you're only having 1, 2. So there's no second 2 to multiply by itself. So that's just 2 to the power of 1 is 2. X to the power of 1 is x. So if you don't have anything up here, it's just implied as 1. So if you do have a number up here, let's say to the power of 2, so x squared, that means you're going to take x 2 times. So here's x number 1, and here's x number 2. And you're going to multiply those by each other, and you end up with x to the power of 2. So if we do this with a regular number, let's say 3 to the power of 2, we're going to need 2 3s. Here's a 3, and here's a 3. And you multiply those together, and that gives you 9. So 3 squared equals 9. Now if you have, let's do a different exponent. Let's say we have 4 to the power of well, that's going to be too big and pain in the butt for me to just do off of my head. So let's say we have 2 to the power of 3. Well, this is how many 2's you're going to be multiplying by each other. So we're going to need 3 2's. 3, 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8. So 2 to the power of 3 is 8. It's not 6. We're not taking 2 times 3. We're taking 2 times 2 times 2. So 2 times 2 is 4, and then that number, 4, times 2 again, is 8. So that's a little recap on exponents. So what does this exponent really mean? If you have the x to the power of 1 and times x to the power of 1, you're going to get x to the power of 2, right? Because this 2 is telling you you're taking x times x. There's 2 x's involved. And so really, if you look at this, all you have to do is add these 2 exponents. 1 plus 1 equals 2. And so you end up with the final answer. So if you have x to the power of 2 times x to the power of 3, you're just taking this 2 plus 3 equals 5, so you get x to the power of 5. So that's multiplication. So let's try some of these and we'll see. And I'm gonna do this a long way just so you can see visually how this plays out, and then we'll just do it the short way where you're just adding them. Okay, so if we have x, and remember if there's no number up here, that means 1. So x to the power of 1, x to the power of 1. So that just means 1x, which is this, times 1x, which is this, is going to be x to the power of 2. If we have, let's go to the next one. If we have x to the power of 2 times another x, which is to the power of 1, well, this x to the power of 2 is really saying what? It's saying x times x. And then this x to the power of 1 is saying times another x. So x times x, which is x to the power of 2, times x, which is x to the power of 1, is 1, 2, 3 x's. So that's x to the third. Now let's take this next one. X to the power of 3 times x to the power of 2. Well, x to the power of 3 means x times x times x. It's 3 x's times each other, right? And x to the power of 2 means x times x. It's 2 x's times each other, right? And we want to multiply those, so we're going to bring this multiplication down. So now we have 1, 2, 3, 4, 5 x's. So that's x to the power of 5. Alright, now let's try the same thing again, but let's see how we can do this in a shortcut, so you don't need to draw that all out every time, because that would be a pain. So if you have x to the power of 1 times x to the power of 1, you just add up these exponents and you get 2, so that's what you're going to end up getting. If you have this x to the power of 2 times x, you're just going to add up these exponents. Remember, this is an invisible 1. 2 plus 1 is 3, so you get x to the power of 3. If you have x to the power of 3 times x to the power of 2, you just add these 3 plus 2 up, it's 5, so x to the power of 5. Which, if we go back and look at what we just did, that's the exact same thing that we got when we drew it all out. So what does this have to do with scientific notation? So we have, let's say we're multiplying, start this top row first. Let's say we're multiplying 1 times 10 to the power of 1 multiply by 1 times 10 to the power of 1. So it's the exact same thing. Just because it looks fancier doesn't mean that it's going to be any harder. We're going to take 1 times 1, which is 1, and then this 10 to the power of 1 and 10 to the power of 1, we just take this exponent, the 1, and this exponent, the 1, add them up, give you 2. So now we have 1 times 10 to the power of 2. And that's it. So let's try this next line. We have 1 times 10 to the power of 2 times 1 times 10 to the power of 1. So first let's just do the regular numbers. 1 times 1 equals 1. And then we have this 10 to the power of 2 times 10 to the power of 1. So we just take this 2 plus 1 equals 3. So the answer is 1 times 10 to the third. Now let's do one more just to make sure we got it. 1 times 10 to the power of 3 times 1 times 10 to the power of 2. So first we take the 1 times 1, which is 1. And then we have this 3 and 2. Add those up, that's 5. So the answer is 1 times 10 to the fifth. And see, I have this done right here real nice and neat, but it's the exact same thing that what we just did. Now here's division. Let's remember what we do in regular exponents when it comes to dividing exponents. Now if you think about it, this x to the power of 2 means there's going to be 2 x's times each other, x times x. And then here on the bottom of the fraction, or bottom of the divisor bar, because this is the same thing, this fraction is the same thing as saying divided by. So this fraction bar means divided by. It's the exact same thing as a fraction bar. They're interchangeable. You can say either one. It's the same deal. So down here on the bottom, there's just an x, and remember that's an invisible 1. So we have x to the power of 2 up top, divided by x to the power of 1. So on the top of the fraction bar, we're going to have 2 x's times each other. On the bottom of the fraction bar, we're going to have just the 1x. So when you're dividing 2 x's by 1x, you're just going to cancel out whatever you can that's the same on the top and the bottom. So let me use red for this. So we have an x down here, so that can cancel out an x up here. So these two cancel each other out. And that just gives us 1x left over. So the answer is x. And remember, there's an invisible 1 here, if you need that. So x to the power of 2 divided by x equals x. Let's do this next one. X to the fourth means there's 4 x's. 1, 2, 3, 4. And x to the second on the bottom of this. And remember, this is divided by. That's 2 x's times each other. We are going to cancel out whatever occurs both on the top and the bottom. So there's 2 x's down here. Those cancel out 2 x's up here. We're left with 2 x's times each other up here, x times x, which is the same thing as x squared. And one more time. We got x to the power of 2 divided by x to the power of 4. Here's 2 x's, 4 x's. We can cancel this out, cancel this x out. This time we're left over with 2 x's, which would be x squared, right? But look, this is on the bottom of the divisor bar, not the top. The other ones have been on the top. This is on the bottom of the divisor bar. So this is going to be, we have to keep that on the right side of that bar. So that's going to be 1 over x to the second. Because, of course, there's an invisible 1 up here. When there's no number, you can just count that as an invisible 1. So that would be 1 over x to the second. Now, another way to write it, if the exponent is on the bottom of a fraction bar or divisor bar like that, is you don't have to write it that way. You don't have to write 1 over x to the second. You can just write x to the negative second, and that's the exact same thing. So x negative 2. So here's the same thing that we did on the other page, but here's the shortcut. Here's how you don't have to play all that out every time. If you notice, go back here for a minute. If you notice these exponents, this is a 2, this is a 1, and the answer was x to the 1. Well, isn't 2 minus 1, doesn't that equal 1? And let's look at this one. There's 4, and there's a 2 on the bottom. And the answer was x to the second. Doesn't 4 minus 2 equal 2? This is exactly the shortcut that you can do when you are dividing exponents. So you take this 2 minus 1, invisible 1 there. 2 minus 1 is 1. So the answer is x to the 1. And you can just write that as x. And, oh, this is supposed to be a 4 up here, sorry. That's supposed to be a 4. So now we have x to the 4 divided by x to the 2. 4 minus 2 is 2. So the answer is x to the second. And now let's take this one down here again. Here's a 2 up here, there's a 4 down there. So what's 2 minus 4? Ah, wait a minute, that seems weird. No, so don't panic, just think about it. What is 2 minus 4? Doesn't that give us a negative 2? Sure does. So that's what the answer is, x to the negative 2. And that's when we were writing it 1 over x to the 2. It's the exact same thing. But when you're doing scientific notation, you want to keep it like this. You don't want to have it in a fraction form. You want to keep it out of the fractions. So when you're doing scientific notation, you want to go for the negative 2, x to the negative 2, or 10 to the negative 2, not 1 over something. So let's do these division for scientific notation. This is just like the x to the 2 over the x to the 1. We have, on this first one, we have 1 times 10 to the second divided by 1 times 10, and it's an invisible 1, right? Well, first we're going to divide the regular numbers. 1 divided by 1 is 1. And then you just bring down the times. And then these 10s are going to stay the same. It's just going to keep that as 10s. And then we're just going to take this 2 minus 1, for the 1. 2 minus 1 is 1. So the answer is going to be 1 times 10 to the 1. Now let's do this next one down here. We're just taking 1 divided by 1, which is 1, times 10, and then our question is, what's that exponent going to be? Well, 4 minus 2 is 2, so the answer is going to be 1 times 10 to the 2. Now let's do our tricky one down here. We're still going to do 1 divided by 1, that's 1, times 10, and then we're going to take 2 minus 4, which is negative 2, and that's going to be our answer, 1 times 10 to the negative 2. Now, if you're unfamiliar with what it means in scientific notation when that exponent is negative, check out my video. It's very, very short. I got it on TikTok and on YouTube. It's scientific notation in 2 minutes or less, and it'll explain the whole thing for you. So here we have it again, just as a reminder what the answers are. Now, what about addition and subtraction? Now, this is a totally different thing. You're not going to be, you're adding and subtracting the exponents when you're multiplying and dividing. I know that might sound weird and confusing at first, but when you're just remember it because it's confusing. Don't shy away from it because it sounds confusing, but remember it because it's weird. When you're multiplying, you add the exponents. When you divide, you subtract the exponents. So, because it's weird, let that weirdness help you memorize that, help you remember that. When you multiply, you add the exponents. When you divide, you subtract the exponents. But so now what do we do when we're actually adding and subtracting numbers with exponents in it? We're not going to add and subtract the exponents like we did with the multiply and divide. That would be multiplying and dividing. So what do? We're going to do a little something a little bit differently, and this is a totally different thing. When you are adding or subtracting numbers with two different exponents in it, you can't. It's like apples and oranges, because this x to the second is like x times x, and this plus x is plus x. So you have x times x plus x, and you can't combine all those together. Why? Because of the order of operations rules. You have to do the parentheses first, then the exponents, then you multiply, then you divide, then you add, then you subtract. You can't combine unlike terms, and these are different. These are not like terms. So, same thing with scientific notation. You can't add 1 times 10 to the second plus 1 times 10 to the first, because these are not like terms. These are different. So you have to turn, how do you do this? You turn these into the same exponents. Like, it has to either end in like 10 to the 1 or 10 to the 2, both of them. And then you can add everything together. So how do we do that? Well, there's two ways. And you could turn everything back into their long form numbers, just get rid of the scientific notation, which is too much work when you're dealing with huge numbers. So I do not suggest that. But you can do that if you stop and get confused and you're really, really lost. It's better than nothing. Or option 2, you just convert one of those scientific notation forms into a scientific notation format that matches the other one, that has the same exponent. And this is faster. And so let me show you what I mean. Here is when you're turning it into, here's the slow way. When you turn it in, you just get rid of scientific notation and you turn it back into its regular number. So 1 times 10 to the 2 is 100. 1 times 10 to the 1 is 10. So then you can add them together and you get 110. Okay, that's not bad, but when you're dealing with numbers, just long numbers, this is way too much. It's going to slow you down too much and it's going to be a pain. So here's the good way, here's the shorter way. We have 1 times 10 to the second plus 1 times 10 to the 1. You can't add those together because the exponents are different. But if you change this 1 times 10 to the 2, that's the same as 10 times 10 to the 1. Because if you have 1 times 10 to the 1, or times 10 to the 2, if you just move this decimal point over 1, then you get 10, and now you just have one more decimal point to go. So 10 times 10 to the 1. And so now we have 10 times 10 to the 1 plus 1 times 10 to the 1. So now these are the same now, you can add them together, or you can add the whole thing together. But then, when you add them together, we're going to add these regular numbers together. 10 plus 1 is 11. And then you just drop down everything else. You drop down the times 10 to the 1. You don't do anything else with these ones. As soon as you get them the same, matching, that's what you bring down, and that's your answer. You don't add them, subtract, and multiply. You don't do anything else to those exponents. You leave the exponent, the exact same exponent as what it is, which is 1. So you have 11 times 10 to the 1. And if you want to convert that back into regular scientific notation, we have 11 times 10 to the 1. You can move the decimal spot over. So now that is 1.1 times 10 to the 2. Same thing. So here's just a repeat of what it is, and these are in the notes in the PDF file you can download for free on my website. So you want to keep these the same. See, these are all ones, and then you can convert it over back into the true scientific notation form is only having one number in front of the decimal and then one number after the decimal. So, I mean, your teacher will probably be fine if you go 11 times 10 to the 1, but true scientific notation form is just having one digit in front of the decimal and everything else following the decimal. So let's practice. So here is multiplication. We have 1 times 10 to the 5th times 1 times 10 to the 4th. Well, we're going to do these whole numbers first. 1 times 1 is 1. Bring all this down. Now this is multiplication, so we're just going to add 5 plus 4 equals 9. Now let's do down here the dividing. 1 times 10 to the 5th divided by 1 times 10 to the 4th. Well, you're going to do these regular numbers first. 1 divided by 1 is still 1. You bring down the times 10. And then since this is dividing, you're going to subtract 5 minus 4 equals 1. So the answer is 1 times 10 to the 1. Now let's do the addition. We have 1 times 10 to the 5th plus 1 times 10 to the 4th. Well, we're going to add these regular numbers. Or no, we can't do that yet. Hold on. And there's a reason why, but we can't do that yet because we need to convert. I'm glad I made the mistake to point that out to you so you don't make that mistake. Don't add these whole numbers first because we have to convert this first because these whole numbers are going to change when we convert it. So we're just going to, and it's random, you just pick one. I'm going to pick the 10 to the 5th and change it into 10 to the 4th. So we have 4s on both of our scientific notations. So that means I'm going to have 10 times 10 to the 4th. Because if you look over here, I'm going to move this decimal spot over 1. 10. And that means I can take this down to 4. 4 is left. So 10 times 10 to the 4th plus 1 times 10 to the 4th. We're just going to leave this one exactly as it is because we don't need to change it. So now we can add these whole numbers. 10 plus 1 is 11 times 10. And then you just leave these alone. Now we got them both matching at 4. And that's how they're going to stay. Now let's try subtraction. We have 1 times 10 to the 5th minus 1 times 10 to the 4th. Well, this time just to do a different one. We already turned to the 5th into to the 4th up there for the addition. So this time I'm going to change this into 10 to the 5th. So how do I do that? Well, if I need to bring that up to 10 to the 5th, that means this number is going to have to get smaller. So I'm going to have to bring the decimal point over here and turn it into 0.1. So 0.1 times 10 to the 5th is the same thing as 1 times 10 to the 4th. And then this is going to stay the same, 1 times 10 to the 5th. We won't need to change that. And this is subtraction. So 10 to the 5th stay the same. We just drop that down. And we go 1 minus 0.1, which is 0.9. So the answer is 0.9 times 10 to the 5th. So the first thing you're going to do is we just multiply these numbers like normal. So 3.1 times 1.2, and that answer is 3.72. We're going to drop down this times 10. We just don't know what the exponent is going to be. So in multiplication, we're just going to add these up. 3 plus 2 is 5. So the answer is 3.72 times 10 to the 5th. Now let's do some division. We have 4.7 times 10 to the negative 6th. Aha, I threw a curveball in there for you. So 4.7 times 10 to the negative 6 divided by 2.1 times 10 to the 3rd. Well, same thing. This is division, so we can just go ahead and do this first. 4.7 divided by 2.1 is 2.24. And then we can just bring this times 10 down. We just need to know what the exponent is going to be. Now this is division, so you need to subtract this number, the top number, from the bottom number. So negative 6 minus 3. Negative 6 minus 3 is negative 9. So this exponent is going to be negative 9. So the whole answer is 2.24 times 10 to the negative 9. Now let's do some addition. We have 7.26 times 10 to the 2nd plus 3.65 times 10 to the 7th. Well, we have to pick one of these and match it up with the other one. They both need to have the same exponent. So in order to change this 10 to the 7th to 10 to the 2nd, I'm going to have to take this 3.65, because right now that's 10 to the 7th, meaning if I were to unfold this, I'd go 1, 2, 3, 4, 5, 6, 7, and there's the decimal. So this would be 36,500,000 is 3.65 times 10 to the 7th. So I need to take this down to 10 to the 2nd, which means I can only have 2 more decimal places moved over for it to be its real number. So if I go back 2 decimal places like this, that's going to give me 365,000 times 10 to the 2nd. So now we have this 2 is the same as this 2 up here. We need to add 7.26, add it to 365,000, which is 365,007.26 times 10 to the 2nd. And you're probably going to want to change that and move the decimal point back. Get a different color here. You're going to want to move the decimal point back behind the 3 so it's proper scientific notation. So we're going to go, so this is already at the 2nd. So then we're going to start at 2. So we're going to move this is decimal move number 3, 4, 5, 6, 7. So that ends up giving us 3.6500,726 times 10 to the 7th. And of course, with scientific notation, you do rounding, so you can just kind of drop those off. So the answer would be 3.65 times 10 to the 7th. So you got this. I know it's a little bit weird at first when you're listening to all this. And so, that's why videos are awesome, because you can stop and you can go back and you can replay, and you can watch this little bit by little bit until you can understand the whole thing. Also, if you want to watch this, but you don't want to sit here for another 40 minutes and just rewatch it and be kind of bored, and you can just jack up the playback speed up to 2 or something. So I'm talking like a chipmunk going real fast through it, and you can always just pause and play it at normal speed when it gets to a point where it's still confusing for you. Pause, work some problems, put it back on play, check yourself. And if you have any questions, please feel free to leave a comment in the comments, and like and subscribe, and download these PDF notes at Suzanne'sTutoring.com. And when you're on YouTube, look for their big red S.